Hello, this is my problem exam 3 tutorial. I decided to do problem 2. Problem 2 was originally I was going to make a switch, a time-controlled switch using a comparator, but I examined to do problem 4, which was explain how to design an op-amp system to calculate plus minus AV1 plus minus BV2, where A is less than 1 and B is greater than 1. Technically, that would only require something like this, but I decided to instead have two of them, both an inverting amplifier and a non-inverting amplifier, and come by and find the difference between them, just to make it a little bit more complicated to get full points. Here is my equation. As I said before, this is the inverting part, this is the non-inverting part. They come together, and right here we have a voltage divider to find the addition of both of these currents. But because this one is negative, this one's positive, it actually is the difference. So the first thing I had to do was create all the values right down here, all the voltages. I did simple, the 1, 1, 2, 2, 3, 3, and 4, 4, just so I could remember them. Here, I created these ones to make my desired result. I wanted the inverting amplifier to have a gain of greater than 1, so V is greater, G is greater than 1 over here, and I wanted the gain down here to be less than 1. So I took a while to create values that would make each of these to the proper gain that I wanted. That ended up being those values. And so now comes on to solving the equation, solving the circuit. The way to do that is you split into two parts. You have the inverting and the non-inverting additions of amplifier, and you need to find the equations for the gain, and then you take both the voltages, run them through the gain, and add them together. The gain on a inverting is negative RF over R1, where RF is this resistor, and R1 is this one in terms of V1. Same thing for V2, it's just R2 instead of R1. And the VO equals gain times V1 plus gain times V2. If you run that through, that's 100 over 50 equals negative 2. And gain times V1 is negative 2, because V1 equals only 1. Now, the same thing here, but this one is 25, which is negative 4. I wanted both of these to be more than 1. That was my goal. Gain V2 equals negative 4 times 2 is negative 8. And when I add those together, which is GV1 plus GV2 equals negative 10. Over here, it's a little bit more complicated. I have the voltage divider here, which ends up down here. Voltage divider here ends up down here, multiplied by the voltage divider here, which ends up down here. Same thing, just switching out this value only between the two different gains. I created these to be less than 1 on both of them. So 0.96 and 0.64. Then you get GV3 plus GV4 equals VO, and GV3 is 2.88, and GV4 is 2.56, and so you end up having 5.44. Now, comes the last part of the equation. You put them together, you have V1 and V2 coming in right here. This is a simplified version of that. I connected the output to, I'm going to be measuring the voltage between this output and ground over the 10 ohm resistors. I chose 10 simply because it was a simple number and have them both the same. On this side you have negative 10, this side you have 5.44. Use the same logic that you do to find the voltage here. down here, which is superposition, by pretending that one of them is 0 and that the other one is 0, finding the equations for both of those, and then adding them together, which is 2.72 for the positive side and -5 for the negative side. And that equals a difference of -2.28, not a difference, an addition of -2.28 volts. And this is the final value after going through all of these op-amps. Thank you. I hope this was good and solved everyone's questions. Thank you.